when talking about energy, we'll have two types, which is kinetic energy and potential energy. And in this video, I will talk about kinetic energy and also another concept, which is work. Well, before giving you the formulas, I want to do a little bit of math. So I have F equal ma, right? I can write this as mn dv and dt. And then what if I want to multiply both sides with ds or dt, vdt? Then I will have we can cancel the dt, so v dv, right? And you notice this one is the derivative of v squared over 2, right? So I can put the m inside, so we will have d of mv squared over 2, and this equals fds. So if you notice, if f equals 0, then the mv squared over 2 inside here doesn't change, because its derivative equals 0. So yeah, and this value, we called it the kinetic energy. So from that we have kinetic energy, which is K equals half of mv squared, and the unit is U, and this is a scalar. And every object that moves would have kinetic energy, would always have kinetic energy. And from the previous equation, we know that if there's no force, then K remains the same value, and this is true for Newton's first law. We look at the previous equation again. We can have dk equals fds, right? But sometimes the force and the moving direction can be different, right? So we want this to be a scalar. Then we can put this as f dot ds. Then we integral both sides, and from here we can have k2 minus k1, or the change of kinetic energy equals fds. Or maybe fs for more simple term. For a more simple term, and we call this work, or W, or sometimes it can be a And we call this the the work and kinetic energy theorem. So these are two things that you should remember about kinetic energy and work.